Alright, let's talk about calculus. The one word that can make even the most confident math lovers take a deep breath. But what if I told you that calculus isn't just about complex equations and graphs? It's actually the foundation of everything from AI to physics, and it even powers things like Google's algorithms and your favorite social media apps. Surprised? Let's dive into what calculus really is and why it's the secret sauce behind modern technology. A quick question. When's the last time you used calculus in real life? Think about that while we get into it. So, what is calculus anyway? In simple terms, calculus is a branch of mathematics that studies how things change. It's all about understanding how things grow, shrink, speed up, slow down, and everything in between. Think of it like a toolkit for analyzing motion and change. Calculus has two main areas: differential calculus, which is all about rates of change, and integral calculus, which focuses on accumulation, basically adding things up over time. Whether you are calculating the speed of a falling apple or the growth of your favorite stock, calculus is there in the background. And no, calculus doesn't just mean endless equation on a chalkboard. There's way more getting on there. Let me explain it with an example. I will first draw two figures which will help to understand. This is figure 1, a straight incline, and this is figure 2, a curved incline. I will write here straight incline, and here curved incline. A load on straight incline, it goes upwards when pushed. A load on curved incline also, which goes upwards when pushed. Assume that both loads are equivalent. For the straight incline, the load has to be pushed with an unchanging force, and the load goes up the incline at an unchanging speed. With simple formulas, you can calculate how many calories of energies are required to push the load up the incline. For the curved incline, stiffness of the incline is changing, and the load has to be pushed with constantly changing force. That's when we need calculus. In calculus problems, we have to break up the curving incline problem into small chunks separately. When we zoom far enough to the curved incline, it becomes practically straight. Then we can solve that small chunk using simple formulas like straight incline. At last, we can adapt the small chunks and get the final result. So, how did calculus even come about? In the late 17th century, two mathematicians, Isaac Newton and Gottfried Wilhelm Leibniz, independently developed the foundations of calculus. Imagine a world where we couldn't measure speed, acceleration, or even changing temperatures accurately. This is what calculus was invented to solve. Newton wanted to understand motion, especially the movement of planets and objects under gravity. Leibniz, on the other hand, focused on finding the area under curves. Despite their arguments about who invented it first, they both changed the world forever with these discoveries. But how does calculus go from solving motion to shaping artificial intelligence? Let's keep going. So, why does calculus matter in the real world? Calculus might feel like just math on paper, but it's actually everywhere. In physics, it helps us to calculate the forces that drive everything from cars to rockets. In biology, it's used to study how diseases spread and how populations grow. And in computer science, it's the foundation of algorithms that can recognize patterns and even predict what you are going to watch next on YouTube. Imagine if YouTube could predict what you want to watch next without calculus. Chaos, right? So, how exactly does calculus relate to artificial intelligence? In AI, calculus helps machines learn from data. When an algorithm tries to minimize error and learn from mistakes, it's using calculus, specifically derivatives. Derivatives help find the best solution by measuring how changes in one area affect another, just like adjusting a recipe to get the perfect taste. And with integrals, AI can analyze large sets of data, find patterns, and even make predictions. This is critical for machine learning models, which use calculus to become more accurate over time. So whether it's recognizing a face or recommending a song, calculus is working behind the scenes. If you enjoyed this breakdown, hit the like button and subscribe for more math and AI content. And let me know in the comments what's one real world problem you would love to solve with calculus.